Hello everybody. I'm Andy from ThinkMo. I am currently teaching the CCIE course. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is function of link local address in IPv6. We also call it a link local address. Next, we will explain it from three aspects. The first one is what is a link local address. The second is the role of link local addresses. And the third one is, how do you get the link local address? Link local address. It is the application scope of IPv6. Restricted address type. Such an address type. This parameter is valid only on the local link. This link is between two devices. Use a line to connect it. This link is what we call the local link. The two devices it connects to. We should actually call it a node. It can only be on the node of the local link. Use between. This is the link local address we talked about. Let's say we have two devices. Between these two devices, it's connected by a line. When one of the devices sends data, it can only be sent to the peer device. Let's say that this device on the other end, with a device attached to the back. It cannot be sent to the peer device. It's attached to this device in the back. This is what we call a link local address. A link local address can act as the next hop in a routing protocol. This is a very important function. Then it acts as the next hop in the routing protocol. We change the address. Normal services are not affected. This means that normal service communication is not affected. Here are some of the benefits it brings. The second aspect is that it can save global IPv6 addresses. It's not really necessary, because for an IPv6 address, it has not used up all the addresses it has allocated. Within 10 or 20 years, IPv6 addresses may not be used up. So it doesn't do that much. And then how do you get the link local address? So before we get to that, we need to reinforce the first two. I've got two pictures here. One is the IPv6 address space. One is a diagram of its structure. The IPv6 addressing structure diagram is shown. And we covered that in the previous video. A description of these addresses. Let's introduce it briefly. IPv6 address. This is an old picture. Some terms at this stage. It's a little bit different than that. So I'll just use some of the current ones. IPv6 addressing terms to explain to you. It falls into three broad categories. Multicast is what we refer to as multicast. When it comes to the concept of multicast, it's in IPv4. Includes the concepts of broadcast and multicast. But there is no broadcasting in IPv6. There is no ARP. So it's just the idea of multicast. So multicast means multicast address. Normal multicast address FF008 indicates that the first 8 bits are fixed. Fixed by prefix. Next is the address of the requested node. It's fixed 104 bits in front of it. FF021 FF00:0000104. To define the prefix. And then there's unicast. It's divided into special addresses. For example, address and loopback address are not specified. The use of an address is not specified. If an interface does not have an IP address, the packet is to be encapsulated. Then you need to use an unspecified address as the source address. A DHCP request is being made. It is when the packet is sent. Just use 4 zeros as the source address. And 128 is the equivalent of IPv4's 40. And then the loopback address. It is equivalent to IPv4's 127.0.0.1 address. It is only available for local network cards. This data cannot be sent to the NIC. The IP address cannot be the source address of the packet or the destination address. Then there is the local link address. It is the link local address. The address begins with FE80. It's 10 bits in front of it. The 10-bit is fixed. It's a binary number. The next step is aggregable global unicast addresses. Its address is 2001, 2002, 3FA. So let's look at the next picture. There are some address prefixes in it. And then there's the arbitrary multicast address. An arbitrary address is a special unicast address. It is not actually used. It is mainly used in mobile IPv6. These technologies are not standardized today. What kind of problem does Runbois solve? It enables nearby access. In some routing protocols, it will be based on the routing level. Shortest path to achieve access. This is the concept of an arbitrary address. We won't go into too much detail here. I just mentioned that. There are two more unicast addresses. This is the local website address. An IPv4 compatible address. This is an old picture. Actually, this local website address. It should now be called unique local address. IPv4 compatible addresses. It should be called IPv4 compatible address. Just a quick word about what these two addresses do. Local website address is the unique local address. Private IP address equivalent to IPv4. Global unicast addresses can be aggregated. It is equivalent to an IPv4 public IP address. Then IPv4 compatible addresses are not used. So it doesn't have a parallel in IPv4. It was in the early days. The compatibility of IPv4 and IPv6 is involved. That is, the transition from IPv4 to IPv6. And then take that address. Map an IPv4 address to an IPv6 address. It's just that this mapping is a little weird. So it's out now. So we don't have to explain too much. Now let's look at another picture. It's about the details of address assignment, such as the detailed address space ratio and so on. First we look at global unicast addresses. An IPv6 public address is involved. The public IP address is 001. The first 3 bits are fixed. The first 3 bits start with a 2. That's the extent of it. Next is the unique local unicast address. The IPv6 address of the private network is as follows. The first 7 bits are fixed. It's 1111.110. The same is true of the range. Link local unicast address. The first 10 bits are fixed. Multicast addresses and other special addresses. An embedded IPv4 address is a compatible address. So that's a little bit about them. Next we are going to talk about link local addresses. It is a link local address. It is prefixed with FE80. The first 10 bits are fixed. The third aspect. The link local address is obtained. There are roughly 2 ways. One is manual configuration. The other is automatic generation. Automatic generation can be divided into 2 types. One is generated automatically by the system software. One was the conversion of communitarized EUI64. It is used by most manufacturers today, like Cisco and Huawei. They're all in use now. What about the automatic generation of system software, like Windows 10 or Windows 7 on XP? It has its own private algorithm. The private algorithm is determined by each vendor's system. Each system decides differently. So we can look at that. For example, in my computer Win 10 system, Let's look at link local addresses. Connect the IPv6 address locally. It's calculated by an internal private algorithm. Then manual configuration is simple. It's you on this interface. Configure the link local address yourself. EUI64 conversion method. This is a key point. It is one that is often used. It passes is the MAC address to do the EUI conversion. So how does it translate? The first step is to bisect the MAC addresses. We all know that a MAC address is 48 bits long. After bisecting, insert FFFE in the middle. Then take the first 7 bits of the MAC address. The 7th bit to be exact. Make a reversal. The inversion is the conversion of 0 to 1. 1 is converted to 0. And finally the head is high. Add the prefix FE80. Link local address. It starts with the prefix FE80. FE 10 bits. For example. So let's take a MAC address. For example, ab.ccdd.1000. Take the MAC address out of the middle. Then there's aab.cc. Leave it out and insert FFFE in the middle. And then the 7th bit in front. We're talking about this The conversion is based on the hexadecimal number A number converted to decimal. That's 10. 10 is 8 plus 2. The binary number is 1010. And the same is true for the second It's also 1010. The 7th bit is 10101. This bit is 1010, 1010. The 7th bit is 1. Convert to 0. And then I convert it. The first one is The result is a 8BB CCFF Fed 1000. In an IPv6 address. A hexadecimal number separated by a colon. Insert FE80 in the head. Now we see that it only has 5 groups. The IPv6 address is 128 bits. There are 8 groups. Each group is theoretically 4 hexadecimal numbers. Now there are only 5 groups. 3 more groups to go. Let's just put a 0 in front of it. Let's add 4 zeros to each group. The 4 zeros in each set are hexadecimal numbers. We've seen that before. We can use double colons for consecutive zeros. So you get a link local address like this. FE80A8BB CCFF Fed 1000. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.